Let's look at significant figures, decimal places, and rounding off, and how to apply it in calculation. So this will be the concluding part on the theory of errors. If you have not watched the video, please check the description box below. So you see the link of the video starting from the beginning. Now, before we start with any of these, let's first look at standard form. How to put a number in standard form or in scientific notation. So let's look at standard form. So look at standard form. A number in standard form. So let's see. You see, a number in standard form will take this form. A times 10 to the power of n. You see this A? It must be a number from 1 to 9. Okay? It must be a number from 1 to 9. Now, take note, whenever you have a number like this, 0.0001406, for example, and you want to put this in standard form, you see, you have to move this decimal point from here down to this first number you have here. Take note, if you move forward outside, you'll be having your n will be negative. If you're moving inside, your n will be positive. Now here, let's move. 1, 2, 3, 4. We move 4 times. So I have 1.406 times 10 raised to power minus 4. Why do we have 4 here? Because we move 4 times. Why is there negative here? Because it is outside. Let's look at another one. What of if I have 0.25? I'm going to move this decimal point down to this first number I have here. I can't start with 0 in standard form. I must start with a non-zero number. So I'll move this decimal point. I'll move it once. So I have 1. So what will now be my result? It will now be what? 2.5 times 10 raised to power minus 1. Why is it minus 1? Because we are moving outside and we move once. Next, what of if I have 350000 like this? If you observe this, there is no decimal point. If there's no decimal point, you assume the decimal point is here. Then you move it down to the first number you have here in order to put it to standard form. So I have 1, 2, 3, 4, 5. So I have 3.5 times 10 raised to power 5. Why is it 5? Because we move 5 times. But why is it positive 5? Because we are moving inside. This example and this example, we're moving outside, it is negative. Here, if we move inside, it is positive. Lastly, if I have 325.456, how do we put this in standard form? Very simple. So you count like this, 1, 2. So you move it to the first digits you have here. That's 3.25456. We move how many times? 2 times, and it is inside. So it will be 10 raised to power positive 2. And that's how to put numbers in standard form. Now, since we've learned this, let's move towards significant figures. Now, that standard form is a powerful prerequisite. Okay, let's look at significant figures. Now, when do we say figures are significant? I'll give us the certain rules to know significant figure. But firstly, significant figures are counted first from the first non-zero number. That is, count from the first non-zero digits. It means that if I have number like this, 9.12, if I have number like this, 4.158, if I have number like this, 0.2, okay, let me just start with these 2 examples first. Now, we count from first non-zero digits. So if you look at it, I will start counting my significant figure from here because this is non-zero. So I have 1, 2, 3. So here I have 3 significant figures. Here, 1, 2, 3, 4. I have 4 significant figures. That is it. Now, the third one, if I have a number like this, can you tell me how many significant figures? 325.426. How many significant figures do I have here? Count from the first non-zero digit. So you have this. So this is 6 significant figures. And that's the simplest part you ever see. So what the next rule? The next rule is that now we will explain all type of zeros we have. We have different type of zeros. Now the first one is that, take notes, leading zeros are not significant. This is the second rule. Leading zero are not significant means that zero that you see at the beginning is not a significant figure. For example, if you have 0.218 at the first question, second one, if you have 0.00912, and the third one, if you have 0.00008, look at what you have. Now, how many significant figures do we have here? You won't count this. It's a leading zero. All leading zero are not significant. So you start counting from here. 1, 2, 3. So you have 3 significant figures. Next, all these are leading zeros, so you will not count it. So I have 1, 2, 3. That's 3 significant figures. And look at this one. All these are leading zeros. They are not significant. This is significant, so 1 significant figure. Correct. Now, we are done with leading zero. Next one, take notes. Captive zeros. Captive zeros or confined zeros are significant. What are confined zeros? Significant. Now, what are confined zeros? The zero that you see between significant figure. For example, if I have 606, how many significant figures do I have here? If I have 606, if I have 60.007, if I have okay. So what do we have here? Check it out. This is a captivating zero, a captive zero between two significant figures. So it means that this zero is a significant figure. Any captive zero you see, zero between significant figure is significant. So I have 3 significant figure here. 3 significant figure. Here, you see these 3 zeros here are significant. Yeah, these are significant figure. And zero that you are seeing in between them are confined zeros. So I have 1, 2, 3, 4, 5. So this is 5 significant figure. Confined zero, they are significant. 1, 2, 3, 4, 5, 6. 6 significant figure. And here, how many significant figure do we have here? Put your answer in the comment section. So let me know you are following. So that's that. So we are done with that. Next one, we have trailing zero. You see, if you see trailing zero or terminating zero, can be significant or not. Now let me explain. So yeah, it can be significant, and at the same time, it cannot be significant also. Okay, let's see. Look at this case, 340, and look at this case, 34.0. Let's see these two cases. You see, this zero here, you see this zero at the second place here. Whenever you see a decimal point, then after decimal point, you now see zeros. That zero is significant. That's the only case where can be significant at the end. Zero can be significant at the end when you have a decimal point. So this 34.0, this is 3 significant figure. But here, there's no decimal point here. There's no point 0. So this is just what? 2 significant figure. You see this 0 here? You see this 0 here? This 0 here is what? Not significant. Take note of that. Okay, what of if I have 25.00? Is this a significant figure? Yes, these zero are significant. Take note, they are significant because you see them after a decimal point. And what do I have here? 4 significant figure. Okay. Now, if I now ask you, what is 90.00? Combine, look at it. Is this 1 significant figure, 2 significant figure, 3 significant figure, or 4 significant figure? See, firstly, take note that I told us that after a decimal point and you see zeros, that zero are significant, right? These are significant. This number is the first non-zero digit, is also significant. Now, what happens to this zero? This zero is a captive zero. How is it a captive zero? Because it is in between 2 significant figures. Therefore, that zero is significant. So let's count. How many significant figure? 1, 2, 3, 4. So we have 4 significant figures. Aha. I like the fact that you are following. Okay. So that's that about that on significant figures. Okay, let's see. Do you know that there's one thing about significant figure? You see this number 900, it can be expressed as, you see, normally 900 is one significant figure. But look at it. If I express this 9 or this 900 as 9 times 10 raised to power 2, how many significant figure is this? Still one significant figure. If I express this as 9.0 times 10 raised to power 2, you know I'm still correct. 9 and 9.0, I've not changed the value. But this how many significant figure now? Two significant figure. If I say 9.00 times 10 raised to power 2, this is still what? Three significant figure. You can see a number can be expressed in, that's why I taught us standard form first. A number can what? Can be represented in different significant figures. All right, take note of that also. Now, we are done with that. Let's look at decimal places. What happened to decimal places is very simple. Decimal places means that the number of digits you will see after a decimal point. The number of digits you will see after a decimal point. Now let's see. If I have 58.2, this is just what? One decimal place, because you see one number after decimal point. If I have 5.80, how many digits do you see here? You see two digits after a decimal point. So here you have two decimal places. Okay. If I have 3.000, how many significant figure you have here? 1, 2, 3. You have three. So how many decimal places? You have three decimal places. What of if you have 3.45678? How many decimal places do you have? You have 5 decimal places. And that's about decimal place. All right. Before we show us how to apply significant figure and decimal places in calculation, how do we apply? For example, if we have digits that we are solving on, how do we put our final answer? Should it be in the highest significant figure or decimal place, or lowest significant figure or decimal place? How do we know? We know by watching this video to the end. Okay, before I discuss that, let's see how to round off. Don't assume you know some of these things, because there are some of these things that will be new to you here. So how do we round off? You see, to round off is very easy. Look at something. If I have something like this, let me say I have 3.4162. Let me say I want to round off this number to 2 decimal place. To what? 2 decimal place. It means that I want to let the number stop at the second decimal place here. Now you will look at the next number. If that next number is 5 upward, if it is 5 or greater than 5, you are going to add 1 to this one. Then it will give you 3.42. Also, if I have 3.4152, you can see this number here. Let me say to 2 decimal place also. Look at the next digit. It is 5. You are going to add 1 to this and you have 3.42. These are correct. Now, next one. What of, you see, if I have something like this, 1.2413, and I want to stop at the second decimal place, that's to 2 dp. What happened? I want to stop here. Look at the next digit. This is 1. Is this up to 5 or greater than 5? No. So you just drop everything and you have 1.24, which is the final answer. What if I have 1.2419 to 2 decimal place? What will you do? You just check this one, or let me say this one is 4, for example. You want to stop at 2 decimal place. People make mistake to say round off, round off. No, just look at this one. Is it up to 5? No. So your answer will be what? 1.24. Now, the last rule that seems ambiguous is this. Whenever I want to, you see, make sure you use this rule when you have 5 at the end, or when you have 5 and zeros at the end. Now, take note. Look at these values. If I have 1.225, if I have, for example, if I have 1.215. Now, take note of something. Whenever your number is ending with 5, or is ending with 5 and zeros, for example, if I have 1.2250000, good. Now, whenever you see any of these keys where 5 is at the end or 5 and several zeros, you have them at the end. Please pay attention to this thing. You see, if you observe the number that I want to put everything to two decimal places, to two decimal places. Now, observe everything to two decimal places. Now, what you are going to observe is this. Please make sure you do something. You see, look at this number here. It's an even number. Whenever the number you have is an even number, are we together? And the last digit you have there is 5. You know that normally by this rule we are to plus 1 here. Because your last digit is 5, and what you're having here is an even number, you will drop this as 1.22. I believe that is sounding new to you. This is odd. This is even. You will not add 1 to it. Since 5 is the last number that you have here. If 5 is not the last number, no problem, add 1. But because 5 is the last number here, and what you have here is an even number, you will not plus anything. But look at this case, where 1 is an odd number and 5 is the last digit. What happened? You just follow your normal rule, add 1 to this, which is what 1.22. Look at this. You have 5 and several zeros. You have 5, you have 5. The same rule bind all of them. So what you have here, if it is even, never add 1 if 5 is the last number, or if 5 and zeros are the last number. So here you have 1.22. So that's that on rounding off. Take note of it. Now, how do we now apply all these solvings in calculations? How do we apply them? Sorry. How do we apply them in calculations? How do we apply them in calculations? Now, take note. Whenever you do addition and subtraction, now put your answer in the least decimal place, in the smallest decimal place. Let's take, for instance, if I have 5.41 minus 0.398. How will I put my answer? Now, let's pick up our calculator and do this alongside with me. Take your calculator, come on. 5.41 minus 0.398. My calculator normally will give me 5.012. But what should be the correct way to put your answer? Remember that whenever you add or subtract, you must put your answer in the smallest decimal place. Looking at these digits, this is 2 decimal place digits, because you have 2 number after decimal point. This is 3 decimal place digits. So how will you put your answer? And this number is in 3 decimal place. You have to put it, you have to round it to the least decimal place. And if I round this number by rounding off, I have 5.01, which is the correct answer. In option, if you see 5.012, it will be wrong. This is the correct one, 5.01. Let me do more. What of if I have 58.2 0.039 minus 2.29679. Now, let's punch our calculator and put your final answer. Okay, pick your calculator now. So I have 58.2 plus 0.039 minus 2.29679. So my calculator gave me, let me cross check everything from my calculator. This is what it gives me: 55.94224 from my calculator. But what should be your correct answer? What should be your correct answer? Now check this number here is in 1 dp. 1 dp. Check this number here is in 3 dp. Check the number here is in what, 5 dp. How should I put my number? It should be in the smallest decimal place. It means that I will round this number to 1 decimal place. And if I round this number by rounding off, that's 55.9. That will be my final answer. So this is the correct way. If you're asked to evaluate this in exam, this is how you should put your answer. Okay. Lastly, let's look at this. What of if I have 58.21 plus 62.345 minus 100.156. Put your answer. Try to work this out alongside with me. 58.21 plus 62.345 minus 100.156. My calculator, hoping I did not make any arithmetic error. From calculator, calculator give me 20.399. Now observe, to put my answer, see, this is in 2 dp, this is in 3 dp, this is in 3 decimal place. And since we are adding or subtracting, we have to what? We have to put our answer in the smallest decimal place. That is, put it in the 2 decimal place. And 2 decimal place, check it out. If I put this in 2 decimal place, see, it means that I'm to round to this second decimal place here. This number is more than 5, so I will add 1 here. So it's just like 39 plus 1. That will give me 40. That's 20.40. This is how I put my answer. You can see. Just like 1 plus 9 is 10. 0 carry 1. So this is what I have. Now, that's about addition and subtraction. Next. Okay, for this addition and subtraction, I think I should give a simple task. Now, put your answer in the comment section for this. 58.2, 0.039 minus 2.29679. So, do this and put your answer in the comment section. Okay, now, how do we apply significant figures in calculation? You see, we apply significant figure when we want to what? Multiply or divide. Now, for multiplication and division, you have to put your answer in the what? In the least significant figures. Least significant figure. That is the smallest significant figures. So let's look at this question. If I have 2.568 times 5.8 all over 4.186, what will I do here? Firstly, do you know what I'll do? Since these are pure multiplication and division, punch everything together in your calculator correctly. 2.58, that is times. If I want to do it step by step, do you know what happens? Multiply this, write your full answer. With this one, write your full answer, then you divide both of them. So my calculator gave me 3.558146202. Now, how will I now put it in the correct answer? Remember, to least significant figure. Here I have 4 significant figure. Here I have 2 significant figure. We already know significant figure. Here I have 4 significant figure. So I have to put my answer in 2 significant figure. And 2 significant figure is what? This is my first significant figure, second significant figure. So I'm to add 1 to this. So I have 3.6. This should be my final answer. You have to put your answer in what? 2 significant figure, because that's the smallest I have there. Another example. What if I have 51.32 times 6.48 times 3.2. This will give me what? Punch your calculator. 51.32 times 6.48 times 3.2. Everything all together. What we have? My calculator gave me 1064.17152. Now put your answer in the word. See, this is 4 significant figure. This is 3 significant figure, and this is 2 significant figure. You have to put your answer in what? In 2 significant figure. This is a task. How can you put this number in 2 significant figure? Very, very simple. See, this is my first significant figure. This is the second significant figure. So I'm to add 1 here like this. So you have 1, 1. You see 0, 0. This is how you should put your answer. I will not put, see, if I put 0.0000, it means that what I'm having here is 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figure. Remember, after a decimal point, your zeros are significant. Therefore, I'll leave my answer as what? 1100. That's 1100. So that is to 2 significant figure. Remember, this is 2 significant figure. Yeah. All right, next, if I have, okay, so that's the rule. So let me just give us, let me just solve one more. That'll be like confusing. So what of if I have 4.18 minus 58.16, then multiplying 3.38 minus 3.01. Look at what I'm having here now. See, I'm having those two rules, significant figure and decimal place. How do we do it? Remember, this is subtraction. Whenever you are adding or subtracting, put your answer in the smallest decimal place. Here, I have two decimal place. Here, I also have two decimal place. So my answer will be in two decimal place. 4.18 minus 58.16. This gives me minus 53.98, two decimal place. Now, times, looking at this one, you have two decimal place. Here, you have two decimal place. So if I multiply that out, what will I have? 3.38 minus 3.01. So smallest decimal place is 62. That's 0.37. 0.37. Now, I'm done with subtraction. Now, I want to multiply. I have to put it in the what? In the least significant figure. This one is first significant figure, and this one is having significant figure. Don't say 3. You can see some of you are saying 3. This is two significant figure. So what happened? I have to put my answer in two significant figure if I multiply out. So times minus 53.98. So my calculator gave me minus 19.9726. So put your answer in what? Two significant figure. And see, 1, 2. Round off, that'll be what? Minus 20. Don't put 0.0. If you put 0.0, you're having three significant figure. So this is my final answer. So that is the end of this video. But before I cut it off, I wanted to do this task. I want to do this. Attempt this. If I have 860 times 10 to the power of 6 times 0.00546 times 10 to the power of minus 2 all over 0.03952. Okay, so remember, multiplication, division to the least significant figure. Thanks for watching this video. Please kindly share this video, refer people to this channel so they can benefit from this. Like, comment, subscribe to this channel. Thanks.